Okay, guys. So today we're going to machine learning concepts. So the next one is machine learning. In machine learning part, we have to know the algorithms. So the machine learning has so many algorithms are there, like regression. It means linear regression and logistic regression and decision tree and random forest. I already told in overview of our first day classes. So guys, today we're going to see about regression concepts. Okay, so before going to these concepts, you have to assume that this example, so this is x and this is y. We can give us it's a chocolates and it's a rupees. So one chocolate is 2 rupees, means two chocolates how much? How much, guys? One chocolate 2 rupees means 4 rupees. 100
Yeah,
chocolates.
yeah, double 200,
Okay, 50 chocolates.
100.
Yes, 50 chocolates is 100 rupees. Okay. So which one is dependent? Which one is independent, guys? X and Y. Which one is dependent? Which one is independent?
Uh, Depends on X, Y is changing.
Y is depending X only. So it is a dependent variable. Dependent variable. And we here we call it as X, we call it as independent variable. Independent variable. Otherwise we call it as input. Otherwise we call it as features. The other name of y is, so we call it as output. The otherwise we call it as target. So all are same, guys, but different name. Okay, so x is a independent variable and y is a dependent variable. Okay, so let me draw the graph using this x and y axis. See the graph. X-axis is, so this is the chocolates, and this is the rupees. So the y-axis is a rupees. So here I point out the point is right. Okay. So the another thing is, so regression means to predict continuous numeric value. Continuous numeric values. So see here it predicted 2, 4, 6, 8, 10, 200, 100. So this is the continuous numeric values, right? Yes, Alkan Gautam.
Yes.
Yes,
So the graph is gone as a linear. So this is called as linear regression because the line extends as a linearly. So this is called linear regression. Okay, so to predict the continuous numeric value and relationship between dependent and independent variables. Okay, so the another one is, so you just take any 2 points, you have to find out the slope of m. The formula is y2 minus y1 divided by x2 minus x1. So just note it down. So 5, 10, and here is 4 comma 8. So which one is x1, which one is x2? So this is the x1 y1, x2 y2. Just apply the formula, guys. Just apply it. 10 minus 8
1 minus 8 by 5 minus 4.
minus 4. So what's the answer?
2
2.
by 1, 2.
So what is the slope value? Slope value was 2. Okay. The intercept point, you just listen. Here is the intercept points. Okay. This is the intercept point. So we call it as b equal to 0. So we call it as bias or intercept. Bias or intercept. Okay, b is equal to 0. Here's we call it as bias or intercept, and here we can call it as slope or else coefficient. We can call slope or coefficients. It has also different names but same thing. Okay, coefficients. Okay, so the formula of linear regression is y equal to mx plus b. This is the formula of linear regressions. It means so linear regressions has two types, guys. One is simple linear regression and another one is multiple linear regression. Okay, just listen, guys. So simple linear regression has, so it consists two part. So one is simple linear regression, the another one is multiple linear regression. So if the axis has x and y, it is called simple linear regression. If in multiple linear regression, it has more x, more than two x's. So x1, x2, period of n number of x's, and it has only one y. So it is called multiple linear regression. So here I draw a diagram, simple linear regression. Okay, this is a simple linear regression and this is the formula of simple linear regression. We just applied, guys. Why? So what's the m value? M value is 2. What's the x value? What's the x value is here? 1 plus b. What's the b value? 0. So what's the answer? If x is 1, so what's the answer of y?
2.
Yes. Now tell me, if x is 2, what is the answer of y?
4.
4. Yes. Now tell me, if x is 50, so what is the answer of y?
100.
Yes. Have you got my point? So how the answer will get x and y? Have you got my point, guys?
Yes.
Yes.
Uh, Again, I tell you, just keep revising. So first one is the machine learning. So in machine learning concepts, so we are applying regression algorithm. Okay, so regression is only using for to predict continuous numeric value, and regression is we have linear regression. So linear regression consists two points, like two types. So first one is simple linear regression and second one is multiple linear regression. So simple linear contains one x and one y, and multiple linear regression has more x's and one y. Okay, so I will write one example for multiple linear regression. So x1, x2, y. 1 3 is 3, 2 3 is 6, 3 3 is 9, 5 3 is 15. Now tell me, so which one is dependent variable? So which one is independent variable? Guys,
X1 is an independent variable.
so okay, it's an independent variable.
Y is a dependent variable.
Is y depends both x, right? So it is a dependent variable, and the both x's are also independent variable. So here we are using multiple independent. So this is called multiple linear regression. If you are using only one x, so it is called simple linear regression. Okay, so this is the example for simple linear regression and this is the example for multiple linear regression. Okay, and this is a formula for simple linear regression, and you know how to find the slope, how to find the bias value. This is the intercept point of, so because the axis, the linear line meets this 0, so then only we call it as intercept point. So this is called intercept point. If it intercept here, so we call it as 7 is the intercept point. If here it is intercept, so this is called 9 is intercept point, but here it meets the 0, so then only we call it as this is the intercept point of simple linear regression. Guys, you just take a snap and take notes later. Okay, I want to move the another concepts. Do you have any doubts here, guys? Okay, just
No.
okay, just take a snap. We will not enter our theoretical concept. We just understand these concepts. Then only it's easy for you. Have you taken the snap?
Yes.
Okay. Okay, guys. I'll remove. Okay. Now see, guys. So the first one is machine learning workflow. I'll write the machine learning workflow. Just ML workflow. The first thing is you have to understand the problem. Okay. First one is problem understanding. So given a simple problem, right? So chocolates and it rupees, right? So first problem understanding. The second one is data collection. Data collection. And the next one is pre-processing. Pre-processing the data. So guys, in these steps we already done in our pandas concepts, right? So we know how to pre-processing the data. Okay. And the next one is you have to find the x and y. You have to find the x and y. Okay, so x is a independent variable, independent variable, and y is a dependent variable. Guys, you have to find the independent and dependent variable. Which one is input, which one is output. Okay. The next one is train test split. Train test split. Okay, so first you have to train the data and you have to send it out testing. So guys, so in our home we are cooking rice, right? Are we checking a little amount of rice if it is cooked or not? Can we do like that?
Yes.
You are cooking a huge amount of rice, guys, in your cooker. So now then you people are checking the few, take a few amount of rices and check if it is cooked or not, right? Is the
Yeah.
same concepts here before deploy the data. So we want to do the train test split. Okay, training testing I'll write the train test percentage. If you are given training as a 70 percentage of data, remaining 30 percentage is going to testing. And if you are given 75 percentage for training, so remaining testing size is 25 percentage. If you are have 80 percentage of data for training, so remaining 20 percentage is going for testing. Okay, so if 60 percentage of training data, so remaining is going for 40 percentage is testing. So these are the data sets. So if I send 20 percentage, guys, if I send a 20 percentage of data for testing, how many data will left for testing? Tell me. So only 5 records are there. How many data are left if it is 20 percentage?
30.
Any one data will going for testing. If I taken 40 percentage of data for testing, so how many data will left?
There is no data.
60%. Right.
Guys, only have 5 records, guys. So if it is 40 percentage we are taking for testing means, so how many data will left?
Other three
But
records, you could say.
Now, guys,
60%.
2 records. 2 records. Guys, it randomly select the data for testing. So if you are applying 40 percentage, it remove it left, it go to testing for any 2 records. If it is 20 percentage, it left testing for any 1 record. Have you got my point? Guys, if you are fitting the test size, it automatically takes the data randomly by randomly. Have you got my point?
so you're taking 40%, so going 3 data. or two data. You are asking for left data, right?
Guys, you have to convert into 100 percentage. We have a 5
Yeah, so
datas, 100 percentage. So 40 percentage means
Yes.
how many records will left for testing?
Testing.
60% will left, so it is more than 50%. So there should be
I'm
three
just
data left.
asking. I'm just asking testing only, not training. So 40 percentage means randomly takes the data. So this is a 40 percentage of record. So remaining three records are the
Hmm.
60 percentage. So have you got my point? So this is the training. So we can split into different data, guys. X train, Y train. So what are the datas will going for training? 1, 2, 3, 6, 5, 10. Now tell me what are the datas going for testing? X test, Y test. Now tell me what are the datas are going for testing? 2, 4,
2 and 4.
4 and 8. So now we split it in a train test split, right? So this is the 60 percentage and this is a 40 percentage of records. Have you got my point?
Yes.
These are going
Yes.
for testing. Guys, we will apply our coding. Don't worry. Just understand the concept. So this is for training data set. We have to testing these things. This two is enough, right? So if we test have two chocolates, this is a 4 rupees. You can easily identify, right, guys? So if it is 4 rupees, sorry, 4 chocolates, it becomes a 8 rupees, right? Yes. Now we are putting train test split, and the next one is model building. So model building means here we are applying the linear regression algorithm because it depends on x and y. So it predicted continuous numeric value. So then only we are applying linear regression. Okay, guys, day by day we will see at least one algorithm. So don't worry. So today we see linear regressions. Okay, and the next one is evaluation metrics. We have to evaluate the model. Evaluation metrics. So evaluation metrics has three types, guys: mean absolute error, mean squared error, root mean squared error, r square score. Okay, r square score. I tell you, guys, just take a snap. I want to remove this. Just take a snap. Have you taken? Guys, have you taken?
Yes,
Yes.
done for myself.
Okay, just a minute. Okay, so now listen. So this is the x and y. Okay. Um. Okay, guys, this is actual value. This is our actual value. The another one is predicted value we have. So this is only predicted by machines only, guys. So we taken as a y cap. So machines also predict the same output, right? Machine also predict the same in report. Okay, so the mean absolute error means difference between actual value minus predicted value. So what is the answer of actual value minus predicted value? So it's a
0.
0, right? So if you are squaring the mean absolute error, 0. If you taken root mean square, 0. So the r square score is 1. So it means 100 percentage. Okay, so it means 100 percentage. If it is 1, better than your model is better. Okay, or if it is 0, the model is poor. Okay, okay, guys. So at least your model should be in 95 to 99 percentage, like 0.99 percentage. or else 0.96 percentage, or else 0.90 percentage. Okay, so if your model is closer to 1, so your model is perfect. Okay, so guys, in case your prediction is wrong, if your prediction is wrong, it will not predict. Just guys, just take a snap, just take a snap. If it is not predict perfectly, so it predicted 3, it predicted 5, it predicted 7, it predicted 9, so it predicted 11. So what will error, what did happen? We'll write some any other value. Okay, so the mean absolute error is 2, and the mean squared value is 4, and the root mean is 2, and it will comes error, guys. So if it is comes errors like a 0.67 percentage, guys, I am approximately writing the thing. Okay, so if the prediction is wrong, the output also will affect. So we will check the R square score is 67 percentage. Okay, we want to check the evaluation metrics, then only we going to deploy. Okay, have you got my point?
Yes.
Just to take a snap, let me go on our theory concept. Now you can easily understand all the concepts, so don't worry. Have you taken? Guys, have you taken?
Yes, sir.
Okay, okay. Let's see. So this is easy for you. So don't worry. So now tell me. So today we're going to see about a linear regression. The first one is regression. So regression is also called as supervised machine learning techniques. Okay. So guys, regression is supervised machine learning techniques, right? So it has a x-axis, so x column and y column, right? So x is denoted as a chocolate and y is denoted as a rupees. So this is a supervised machine learning. So what it does, guys, it used to predict the continuous numeric value. So relationship between whom? X and Y, dependent and independent variable. So the example is predicting house price based. We have the use case, guys. So the next day 13 we will see the multiple linear regressions use case. Okay, don't worry. So now see, linear regression means it is also supervised machine learning algorithm to predict continuous. We can write anywhere target variable or Y, or we can use as a continuous numeric value. Relationship between what? Linear regression means one or more independent variable x. We want to predict which one we want to predict. We want to predict the y. It may have one x or more than x. So then only we return as an independent variable. This is the another definition, guys. So what it has? It has a dependent variable, or else we call it as target, or we call it as output. Simply we tell us y. Okay, so we call it as one or more independent variables or features or inputs. We simply call it as x. So we want to find the best fitting straight line. Okay, I told right. So types of linear regression. Simple linear regression has one independent variable. It means it has one x. Multiple linear regression has a two or more than x. So then only we call it as multiple independent variables. Okay, so this is a formula of simple linear regression. Y equal to mx plus b. Now tell me, so y is a predicted value and x is a input, or it is a independent value, or y is a dependent variable, right? So we already see in our graph, right, guys? So m we call it as slope or coefficient, and b we call it as intercept or bias. Okay, so see, this is the y value. When x becomes 0, when the point meets as a y-axis, we call it as what? Intercept. Okay, the slope means we taking two points like x and y. Okay, so just assume that this is y and this is x and y. So experience is we taken as x as an input and salary is a y. So this is our output. Now tell me, guys, if you have 1 year of experience, your salary is 20,000. If you are 2 years of experience, your salary is 30,000. So now tell me, if you're 5 years, so your salary is 60. Now tell me the another. If you have 6 years of experience, what's your salary? Just
70.
predict, guys. Predict it. If you have a 6 years of experience,
70.
70,000. Yes, right. Okay. Don't you no need to memorize these concepts. No need to apply this formula. I already told, right, the slope formula is y2 minus y1. Don't get confusing this formula. Okay. So in interceptors, 10 is the value. Guys, we no need to memorize this formula. We will just simply apply our code. Just note down the points. Okay. So we will got as a slope as a 10 and intercept as a B is a 10. Now we apply. So if you have a 6 years of experience, what's your salary? 70,000. Okay. Now we need to separate X and Y axis. So this is our model evaluation matrix, guys. I already told, right? So mean absolute error, mean squared error, root mean squared error, R square H square. So mean absolute error means difference between actual minus predictor. The average of squared error. This is the square root, and this is the R square score. If the closer to bet 1, so it is the model is better. Okay. So you just read it out. Okay. So I'll scroll later. Okay. Guys, we need to install this library. Pip install scikit-learn. You can install on your command prompt. Okay. So first step. Now tell me. So pandas we are using for data manipulation and analysis, and matplotlib we are using for data visualization, and numpy we are using for mathematical operations. Okay, so in sklearn mainly this is a framework, guys. This is we are mainly using for our machine learning. So this is our machine learning concepts. First we are taking linear model, we are importing linear regression, and the next one is model selection, we are importing train test split. Next one is matrices. We want to import the mean absolute error, mean square error, R square score. Guys, actually it's R square score, but in the developer already developed the R2 score. Okay, so this is a R square score. Okay, don't get confused. Definitely, guys, definitely we will write it as a smaller case. Okay, don't change anything. So whatever it presents. So first thing is capitalize, so you can write the same thing. Okay, it will occurs error, guys, so you should write the same functions. Okay, now tell me. So the first one is data collection. Is easy for you. So you are collecting as a dictionary and convert into using data frame converted into table format. Do you have any doubts? Do you have any doubts, guys, here?
No.
Okay, now see the next one. So this you have to separate the X and Y. It means input and output. Which one is input? Experience is input and salary is a output, right? Is
Yes.
the next one is train test split. You just apply the train test split function before you can give the variable x train, x test, y train, y test. Okay, you just apply x and y. So this is called 40 percentage. Okay, 40 divided by 100 means 0.4 percentage. The testing size is 40 percentage means, so it randomly takes testing for any two records. It randomly takes records for any two records. So the random state is 42, guys. Okay, so if the number is returns as a 42, it going to be testing size. You just count the number 1 2 3 4 5 6 7 8 9 10 11 12 30 40 15 60 70 80 90 20, again again 25, again 30, again 35, again 40, 41, 41,
32 next one.
42.
42. It automatically, guys, it automatically returns the when the number becomes 42, it automatically takes the two records, right? So it taken this record, it means here, and the another record is which one? So another record is last, so it randomly took the two records, right? So because our testing size is a 40, if your testing size is a 20 percentage, it randomly took only one record. Okay, so based on the random state. Okay, if the number count is 42, it picked for testing. Do you have any doubts, guys? You can check, you can check anything, x train or x test, y train, y test. Here I am checking x test. So what are the data going for X test? Do you have any doubts?
So random state we can take by any number we can take.
Yeah, like we can give any number. So mostly the companies are for using 42 or 101 or some constant value.
Okay.
Hmm. And the next one is a model building. So you just apply linear regression. You no need to memorize the formula y equal to mx plus b. They are only asking for interview. So they already building linear regression function. So if the function it is function, so we don't call it as a variable, guys. So this is a object. So if it is function, this is we call it as object, model object. So here we fitting the model object, so x train, y train. So these are the datas are going for training, so remaining datas are going for testing. Okay, have you got my point? So now we are going for training. You just predict, model predict function, you just give the, guys, we only giving the x test only. Okay, only giving the x test only for prediction. Okay, you no need to memorize the slope formula and intercept formula. Just give a simple command, model dot coefficient, model dot intercept. So this is the zeroth index. So we directly get the answer. Slope answer is 10 and intercept answer is 10. So guys, it's very easy. So just you have to understood the concepts. Okay, do you have any doubts here? Okay, let me move on another. Guys, the here we are finding experience 6. So if you have a 6 years experience, what's your salary is 70 percentage, sorry, 70,000. So it means you're giving as a data frame and you just predicting the new data. You're just predicting the new data. So the new predict is what? So the new predict is 70,000. Guys, why I'm giving zeroth index means, so if I am not given this zeroth index, it returns as an array. So it returns as an array. So then only I am giving the zeroth index. Have you got my point? Is
So the predicted data is getting stored in data frame. What do you say? The index, array index.
is zeroth
That's why
index.
you are printing out the 0th index.
Yeah.
Okay.
And the next one is evaluation model. We just given the mean absolute error, mean squared error. So before you are using, we already initialize our, this is our required libraries, guys. We need to import this, then only you can use the function. Okay, you can give so y text means actual value, y predict means predicted value, guys. So this is the actual value, so this is a predicted value. Okay, so y test is actual value, y predict is a predicted value. Just give, we are giving the data and you just using numpy, you just take a square root function and r square score. So using model evaluation matrix, see the answer. So all are 0 errors, so errors to become a 0. Okay, but the score is a 100%, right? So it's a, the score is perfect, so accuracy is 100%. Okay, have you got the point? Is
So the mean absolute error. Okay, okay. The errors are needs to be 0.
errors is
Then
0.
your model is correct.
Yeah,
Okay.
and we no need to memorize this formula. I'm just for extra knowledge. Okay, so see the graph. So I already draw, right? So the intercept point is 10, guys. See carefully. So the point will intercept as a 10. Okay, so just to see, scatter plot means here I given x train and y train data in blue color, and this is the label. So the blue color is for training data. You can give x test and y test is green color. So green color is the testing data, and plotted line. So if you are using plot function, this is a plot line. So you just give x and this is a predicted value. So if you are given predicted value, it automatically predicts as a straight line. Okay, and you know the x label, y label and title. So the legend function returns the legend, And do you have any doubts, guys, here? So you already knowledge in pandas, matplotlib, and seaborn. Do you have any doubts here? Guys, do you have any
No,
doubts?
What is the grid function?
Hey, grid function true means automatically
all
returns
the
as a
all the
pattern.
grids are
Remember?
displayed. Okay,
Yeah,
correct.
we needed, right? So we want to
Yeah,
see
yeah.
the point. So 32, it's a 30,
Correct,
right?
correct, correct. I
2 years
understand.
means
I
30.
understand.
That's all. So I'll just scroll upon at end of the video. Guys, definitely you have to take the notes, guys. You have to write on your notebook, and you can only put on your coding on your VS Code. It's enough, okay? Because the concept is very, very important from machine learning onwards.
yeah, Vasant, I did not understand this one.
Which one, Alka?
That you scrolled just now.
Sorry?
Yeah, about this